The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons.
Hello everyone and welcome to the .NET Core podcast, an award-winning podcast where we reach into the core of the .NET technology stack and, with the help of the .NET community, present you with the information that you need in order to grok the many moving parts of one of the biggest cross-platform multi-application frameworks on the planet. I am your host, Jamie GaProgMan Taylor. In this episode, I talked with Maarten Balliauw about how JetBrains and many of the other IDE manufacturers are building remote development tools, what they are, and how they work. Along the way, we cover the differences in the amount of effort required to onboard new developers when you have to manually install all of the supporting tools, spin up VMs, and ensure that the source code remains secure versus using something like Spaces from JetBrains. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. So, welcome to the show, Maarten. I'm very excited to talk about what we're talking about now because, to me, this idea of remote development and not having to have the world's most powerful computer in order to do the work is very exciting to me. We'll come back to that in a moment, but I love this idea of being able to use, and I dislike the term, but I like the technique, and that's, back in the day there was this thing called a dumb terminal, right? It was just a computer that just connected to a server. We're going back towards that. I'm very excited. But before we do all of that, welcome to the show.
Thank you very much. I'm super happy to be here, so thanks for having me.
Hey, not a problem. Would you mind just sort of introducing yourself to the listeners, giving them a bit of a flavor of who you are and the work you do?
Yeah, exactly. So I'm Maarten Balliauw. I live in Antwerp, Belgium, so that might be close to you, might be far away from you. I'm a developer advocate at JetBrains, and that is both developer and advocate. So I try to develop on some of our tools, the Azure plugin in Rider, for example. But I'm also a developer advocate trying to get people excited about all of our .NET tools like ReSharper, Rider, and even things like Space and remote development. So pretty much everything. My heart lies with web development and everything cloud and all the architectures around that as well, which is surprisingly similar to how IDEs work with message buses and communicating between different parts of the IDE and so on. So I think that's a really good fit to be at JetBrains and building that kind of tools as well.
Excellent. I do. I was trying to explain, so for the listeners, we're recording this a little ahead of time. At the time of recording, I've got an apprentice that I'm working with, and I'm sure he won't mind me saying, I don't want to work in web because web's not where the fun stuff is. And I'm like, trust me, web is where the fun stuff is. And if you can get the web stuff, if you can get your head around how web stuff works, you can make asynchronous desktop apps. It's the same idea. It's just a different technology stack, right?
I would almost even argue that it's more difficult to work on desktop versus web, because on web, at least with React and stuff, you still have state management and all of those things. But the typical client server, make a request, get a response back is stateless. It's perfect. It's bliss. You don't have to care about any of that state management.
That's very true. Very true. We've been playing around with .NET MAUI as part of their project that they're building, and we'd started working with it 2 weeks before it was like officially released as a version 1. The state management and stuff that goes on with that is it's fun to deal with.
I can imagine. Yes. Yeah.
Excellent. But we're not here to talk about .NET MAUI. We are, like I hinted at earlier on, we're talking a little bit about remote development and some of the tools that are available. Now, we got talking originally many moons ago, about JetBrains Fleet. And I was very excited then, and I'm as excited now, right? Because this is, I'll let you give the proper, brilliant introduction, but my layman's term vision of it is like, I can install this tool, I can push a button and it will spin up maybe a container or something somewhere for me to run my code in. And I don't have to have the world's most powerful computer in order to do my development work anymore.
Yeah, exactly. Yeah, I can give you a little bit of a background, or a little bit of the story around what is available. So at JetBrains, we've historically been building IDEs. I think we started with IntelliJ for Java developers. And a lot of our other tools like WebStorm, PHPStorm, DataGrip, Rider even, are built on top of that IntelliJ platform, which is really, it's an open source project. Actually, Google is using it to build Android Studio as well. But IntelliJ is, I'm not going to say too old, but it's fairly old, and it's quite mature in that. But it also has its own opinionated way of doing things. And that's why we also started thinking about Fleet, a new next generation IDE, which would take the learnings that we have from building IntelliJ for 20 years and trying to see where we would end up if we were building a new IDE from scratch with everything that is out there currently and everything that we have learned over time. At the same time, remote development became a thing. You have lots of vendors popping up that see the benefits of doing remote development and that. And with Fleet, we thought, okay, let's take that angle from the get-go. Let's start building Fleet as a distributed IDE that can run on one machine, but that can also run kind of split brain, where you have parts of the IDE on different parts of your ecosystem. So it could be a VM, could be your local machine, could be a Docker container or whatever. And to make things even more complex, at the same time, we also started building remote development into IntelliJ, which became our JetBrains gateway client, where you can just run IntelliJ as a server somewhere, connect to it, and then work locally. So that's more or less how things fit together, or the differences between all of those things.
Wow, so there's an awful lot going on there. An awful lot going on, and yeah, like I said, it's super exciting to be able to have this, right? Because you've said all of those things. You've said quite a lot, and like I said, the first thing that came to mind was what I said earlier on, right? I may no longer have to have an incredibly powerful computer. Maybe maybe I could just. I'm guessing this is hyperbole. This is me just taking your example and running with it. Maybe I can use a relatively cheap, not so powerful throwaway laptop to then do my development, right?
Yeah, absolutely. So that's a really interesting one. So at JetBrains, we are working on our own backend for remote development, where you could go into our space tool, go into any repository, and essentially click open in IDE, which will spin up a VM for you, which will set up the connection and everything so you can get started. At the same time, we're also working with a number of partners. For example, Gitpod is one of our partners. They also do something similar. They handle the orchestration of spinning up everything in the backend and then connecting our IDE to it. And I know one of the developers there is actually using Gitpod to build Gitpods. And what they have is, I think, a Chromebook or like a really underpowered device and just working remotely all the time with the IDE running on a more powerful server.
I like it. And you'd said about you could perhaps have a hybrid setup. So you've got your super powerful computer, but maybe there's something that would take loads of horsepower to do. You might be able to shove that part of the code off somewhere else and go, hey, do this, right? This is me talking. This is not you talking. This is not JetBrains talking. But my example might be, hey, I have this machine learning model you need to go generate. Go do that somewhere on my super hyper powerful server with a billion cores and 18 kajillion gigabytes of RAM. And then when you're done, give me the file and I can carry on with what I'm doing, right?
Yeah, that's indeed the idea. So most of the week, I might be working on some codes that could run on any type of common VM with a, let's say, 8 or 16 gigabytes of RAM. And then once a week for a couple of hours, I need this hugely powerful machine that has a graphics card that has 25 teraflops. I don't know what I'm saying even, but like a really powerful machine. You could just spin that up, connect to it, and develop there as if you were working locally, but just have more power available.
I like it. There's a lot to be talking about here, and a lot of stuff there. And I really do like that ability to do that work remotely. The work that I do is 100% remote, and it was 100% remote for a little while before the world went all wobbly. We tend not to talk about the current situation, right? Because we don't want to talk about it. But before the world went wobbly, I was fully remote as well. But it meant that I needed, a powerful machine to be able to do all the work. But I like this idea that I maybe don't need to anymore. But also, I feel like it'd be quicker for onboarding people. Is that a benefit as well?
Yeah, absolutely. So there's even a couple of additional benefits. Like if you are a consultant and maybe you work for 2 different customers every week. I've been in that situation where I was a consultant and I actually was carrying 2 laptops around, one for each customer. In this case, that laptop could be something remote and you just log on and work in the ID at that customer, maybe even have it pre-configured for you and everything that is there. So that is essentially one of the real massive benefits, I think, in terms of remote development, is that, first of all, everything can run on the infrastructure or the cloud of the customer you're working for in that case, which means you get more security. There's no code on your laptop if you're sitting on the train or on the tube and you lose your laptop. The code is still in the cloud. It's not on that laptop, so that's a good thing to have. The other thing is, like you say, onboarding and standardizing the remote development environments. We call that orchestration, and that is something that Space does, that Gitbot does, that GitHub Codespaces does, for example, as well, where essentially you give the orchestrator a Docker file and you say, look, I want to work on this Ubuntu virtual machine, install the latest .NET versions for me, install the Git tooling. By the way, I customize my terminal like this, also make sure that that is pre-configured, and the next time, boom, you have the exact same environment. Could be a completely new machine, but the Docker file is standardized and you get the exact same machine. So if you would onboard someone, they would also get that machine with those tools installed, and it would start off the same for everyone, instead of having this massive Confluence document or something where you explain to the team how to get started, how to set everything up.
I like that because, I've looked into sort of automating onboarding people in the past, and there's, loads of different tools for different things. There's like Chef, Ansible, Puppet, all these kinds of things. And I found that the majority of them are kind of a little bit fragile. Like, if you're scripting setting up a machine and you're saying, this is my own personal experience, right? This is not me saying, hey, they are or they're not. You're scripting it and you're saying, right, install this particular version of this tool because it's required. And that tool is then maybe deprecated and you don't know or you don't realize, or maybe you're installing something that has a direct dependency on a specific version of a binary that your operating system ships. Actually, I had this not so long back. I started working on a new project and we were writing some Python code, and it required a specific version of Python. And then partway through the project, I was using an Ubuntu-based system. And it popped up saying, hey, you need to update your OS, otherwise you won't get any support anymore. And I'm like, okay, I'll do that. Yeah, sure, update. And when it rebooted, nothing worked because they'd forced upgrade onto Python, like the vNext version, which had a whole bunch of breaking changes. And I was like, well, that's kind of no good. This isn't me. I'm not trying to say a bad thing about Ubuntu or Python or anything, but that can happen even in the Windows world, right?
Yeah, exactly. I think in past years, we have all been working on getting a better DevOps cycle and scripting your environments, essentially infrastructure as code, where the target environment for your application would be scripted and would be reproducible. If you need to spin up a new staging or development environment, you could do that using the same scripts. But remote development is interesting because there you are essentially standardizing your developer workflow as well. So you are making sure that the development environment starts off the same for everyone. And the interesting bit there is because we source control everything. You write your code in source control. Maybe you're working on a feature branch or whatever. You could also customize the environment for that specific branch with additional tooling, newer versions, or whatever you want to do. And everything who would spin up a new environment based on that thing would have that new development environment available.
Yep. And all of the magic of things like tools embedded into certain paths, all of that's taken care of, right?
Yeah, exactly. It's even nicer. With Space, we do this, and I know some other vendors do this as well, where a lot of those systems that orchestrate your remote development environment work on the basis of Docker, because there's lots of images that you can use and reuse and get started with. What we do in Space, for example, to prepare your development environments is we already built the Docker container so that the next time you run it, you don't have to go through all of the build steps. And maybe if you're downloading half of the internet, then you don't have to wait for that and the environment can get started more quickly. What we also do there is the first time we built that image, we launch the IDE that you will be using on there as well, so that it already has indexes of your code and everything. So the really interesting thing there is when you click open in IDE, you essentially really have a ready-to-go environment with everything preloaded, everything warm. If you want to npm install and again download all of the npm packages that you need in your project, we have that ready for you so you can get started immediately. The downside of that is, of course, you don't have much time to wait for things and go grab a coffee, but I think that's a good thing over time.
Yeah. You see, that's something that I think perhaps not a lot of developers think about, or maybe they do and they're just not very vocal about it when talking to me, is the time that it takes from, okay, so I've got my operating system, I've got my tools installed, now I'm going to git pull the code, or check out the code somehow, right? I'm going to get the code to my computer. And now I want to build it. Okay, but before I do that, it's got to restore all of these dependencies. Like you said, maybe NPM, maybe NuGet, maybe Ruby, whatever. Ruby Gem, sorry. And then there is, like you say, it's got to pull that from somewhere. Maybe it's pulling from an internal server where everything's being checked off, or maybe it's just pulling it directly from the outer repository, whichever way works for you. But that, like you said, it's a process that takes time. And then once it's done that, whatever tool you're using will likely have to recache all of your code and the dependencies to give you that wonderful IntelliSense or autocorrect or whatever you want to call it experience. If I hit dot and it just fills in a menu for me, because that's all got to be, like you say, that's got to be warmed up. That's got to be ready for you. And it's these. I'm worried about saying micro optimizations. I don't want people to think, oh, it's only half a second or whatever. But this is like tens of seconds, minutes of time, right?
Yeah, absolutely. There's a small tangent I want to make here as well, and that is because a lot of people might have never tried remote development in that case, or haven't really looked into it. So it's not like you are connecting to a virtual machine using remote desktop or VNC or whatever. In our case, and I know in a lot of competitors' cases as well, you would connect to a remote machine, but the machine is running your IDE, but the UI of your IDE is actually running locally on your machine, which means if you are typing, if you're editing code, things go smoothly and go fast without you having to wait for what is essentially images being streamed from the server to your desktop. You have the IDE running, and you're sending commands over the wire back and forth on what should be changing and what you want to be doing.
Excellent. Yeah, that's because that was going to be my next question, was like, without giving away the secret sauce, how does it all work, right? And you've just answered. It's got this connection that it uses, and it's passing, like you say, your commands, your keystrokes, your mouse movements directly backwards and forwards, rather than, because like if folks don't know, if you connect to a remote desktop or a VNC server, it's mirroring the visual of what would be displayed on that machine on your machine, right? So it's got to almost like stream the video backwards and forwards.
Yeah, and in this case, it's actually better than just sending keystrokes over the wire and mouse clicks over the wire. So the way in the JetBrains IDEs, IntelliJ, WebStorm, and all of that, if you're working with remote development, the way it works is we have a shared view model between client and server, or between your client and the IDE that is running remotely. So just like you say with MAUI and state management, we essentially have a view model running that knows about the inspections it should be showing for a particular line of code and so on. It knows about the IDs, it knows about the icon ID that should be displayed, but all of that is in the view model that is sent back and forth between the server and the client. And whenever something changes, whenever there's a new inspection to be shown, the server essentially pushes a new ID and icon ID and description and whatever into that view model, and the client will render it for you. So it's actually smarter than just sending keystrokes over the wire.
I like it. So let's say that I've got some code base and I want to run it entirely locally, right? I can still do that, got I, right? And or do I have to have something that's there? Or like how? Yeah, let's say that, right? I can I still run everything on my machine locally, or do I need this server component just to be sitting there ready to go?
It depends on how you want to work. So you can still, the IDEs are there. So if you are using Rider, for example, you can build your ASP.NET apps locally on your machine, run and test everything locally, and that will work out just fine. But then again, maybe you are on an underpowered device and you want to work with the code remotely and get a powerful machine backing your code and doing everything. You launch it remotely and then things will start and you can work on that as well. An interesting thing, ASP.NET, for example, is really cool, in fact, with remote development in Rider. Your IDE may be running remotely. If you debug your application, the application is also running remotely on that server that you're using. The debugger is also running remotely on that server that you're using, but you still, of course, get to inspect everything on your machine. What I find really cool in what we've built is that we also detect ports that are being opened on the server on the remote. So if you run your ASP.NET application, it might open up port 5000 and listens for HTTP requests on localhost. But the thing is, localhost in that case is your server because everything is running there, right? So what we do is we detect when that happens and bridge the connection so that on your local machine, on your actual local host, we forward that port over the same wire that we have with the server. And you can run in your own local browser, your local host port 5000, but it's going to be whatever is running on the server that gives you back the response there. So it feels like you're running locally, but it's essentially running on the remote.
Right. That to me is a wonderful bit of value add. I mean, it's probably not a value add product from yourselves, but like as a developer, I don't then have to mess around with like IB tables or my hosts file or whatever. It's all taken care of, right?
Yeah, exactly.
I like it.
Of course, there's a couple of, and this is going into detailed territory, but there's a couple of weird things as well, where in the case of ASP.NET, for example, you get this developer certificate that will be generated on the server, on the local host that is your server. Whereas on your actual local host, you don't have the same certificate because you're on a different device. So you get an SSL warning. So you have to do some trickery there as well. But in general, it will all work out of the box and look like if you're working remotely.
I like it. You see, I'll take having to do trickery if the majority of all of the setup is done for me, right? Because I can imagine that in a different situation, if I wasn't using, the remote development tools, if I was actually running it on a server, I'd then have to do something like ngrok or something to bridge that connection, and I'd have to manage all of that magic, or maybe use Tailscale or something like that, right? I have to use some other app to map that all for me. So usually I'm against magic, but when it's magic that takes away all the stress, I'm happy.
Totally agree, yeah.
Yeah, okay. So let's just really quickly talk about the difference between a VM and orchestration, right? We've hinted at it a little bit about when we said, you're not using a VM, you're orchestrating something in the cloud, and you're not connecting to it via remote desktop, right?
Yeah.
So because I know that there's a lot of devs out there who maybe haven't had the experience of setting up virtual machines and setting up servers and stuff. I was wondering, could you just really quickly give us a brief difference between spinning up a VM and orchestrating your entire workforce or whatever?
Yeah, I think spinning up a VM is very similar to how you would set up your local machine. So what you would have to do is, if you need this big machine with lots of memory and lots of disk drive or graphics cards or whatever, you would have to first of all, get a cloud provider or get a place where you can run that VM. Next, you remote desktop into it, or you VNC into it, or you SSH into it. And then you have to start setting things up, install all of the tools that you need, clone the repository, make sure that you have certificates, user accounts, all of those things ready to go. And only then you can start working. You also have the downside of it being a VM. And like we talked, instead of So with a VM or a remote desktop, you would essentially be streaming the video card of the remote server to your local machine. If you're on a high latency connection, or imagine I'm in Belgium working on something and my VM is somewhere on the West Coast because the company requires that, you would incur latency and things would not feel as snappy as you would want to work. So there's a number of downsides to that. It's a good approach. It works because the code remains remote, nothing on your machine. So you get that benefit. You can use a big VM. You get that benefit as well. But it tends to work against you because you have to set up the VM and you have that problem of potentially incurring latency because it's a remote desktop that you're working with. Orchestration with remote development is sort of like a nice way. So in Space, for example, on Gitpod, for example, you still get a virtual machine. But what the vendor does in that case is they run some of their tooling, some of their magic on top of it to help you set up that VM so that it can be used by you. So what we do in Space, for example, is that you would set up a Docker file. You could say, okay, I want this Docker file to be based on the latest .NET 6 SDK. You can install Git on it. You can install whatever tooling you may need on there using just Docker commands, essentially. So if you want to try this out, see what your VM or your machine is going to look like, you can run it on your local Docker that you have on your machine, get things set up. And then what the vendor also does is make sure that when you launch that Docker file, it maps a volume with the latest sources that you can start working on. It might open up the IDE beforehand to do all of the indexing and give you all the IntelliSense kind of things as well. So it essentially automates a lot of that manual setup that you would have to do otherwise. And we talked about this a little. You have Terraform and you have all of those tools to set up a VM as well. There's an absolute benefit to that. And if you are using the traditional VM way of doing remote development, absolutely go for tools like that. But it doesn't take away the downside of running it and where you still have to connect over remote desktop, get that latency and all of that. An added benefit is that because it's a Docker container and your source code is going to be mapped on a volume in that Docker container on the remote machine that is running, it's also very easy to upgrade that Docker container. You need new tooling, switch a branch or whatever. You spin up a new container, reattach the existing volume with all of the user home folders and source code that you may have, and you're ready to go again. You don't have to make sure that everything is pre-configured or reconfigured, connect to it, install things. All of that is there, and it's easily to swap it out with a newer version of things.
Excellent. I love the simplicity of it, right? Because plus I'm guessing there's an element of speed, right? Because if I'm having to spin up a VM on demand, now let's just take away the cloud for now, right? If I'm having to spin up a VM on demand on-prem, assuming I have the hardware, I've got to go get the installation media. I've got to sit and run through the installer, set up all of the partitions or whatever. Then, like you say, I've got to get all my tooling, got to set it up, got to get that right. Then I've got to pull the source code from somewhere. And that's just getting me to the point where I can log in.
Yeah, exactly. And that is taken away by all of the orchestration that you will have. Most are working in a similar way, like Space and Gitpods. They're both using Docker containers. There's typically some YAML files involved as well to just set some specifics like which IDE you want to load and all that. But in general, once you figure out how one works, then the other ones will be easy to try out as well.
Sure. Okay. So how do I go about, let's say I'm convinced here's my credit card, let's do this, right? And I want to replicate my local environment. Is it just a case of, well, you know, what am I running locally, right? Choose that Docker container. Which tools am I running? Choose that Docker container. Choose these options. Or is it a case of, right, okay, I've got to start from scratch. I've got to bring up a Docker, like a Docker container file or a Docker, what's the command now?
Docker Compose or?
Yes, thank you, Docker Compose. You know, maybe I've got to fill in a Docker Compose file and say, well, I need this image, I need that image, I need these ports mapping to those ports. Is it automated, or is it or partially automated, or is it completely manual?
I'm going to disappoint you there. That is completely manual. So the way most of the vendors work, and that includes space, is that there's typically this pre-configured environment that has lots of tooling installed. So like for space, I think we install several JDK versions because maybe you want to do Java development. I think we have 2 versions of Python installed. The latest .NET is installed on there. I think there's a PHP interpreter as well. So just like a generalized fits most of the cases type of Docker container that you can get started with more easily. Now, of course, all of those tools take space. All of those tools may be running in your target environment. So maybe you want to simplify things. And that is where you start customizing with your own Docker container. The way you go about that is completely up to you. I'm a big fan of using, for example, the .NET 6 SDK container as the base image for whatever I'm doing. I know I have a colleague who is working on their private stuff, and they actually have Ubuntu, and they use the .NET installer to essentially achieve the same points, getting to develop .NET code on a remote machine. But it's preference and, I guess, standards on how you want to do things. I want to make another tangent there, if that's possible. So you mentioned Docker Compose. That's a really interesting thing that also tacks onto the benefits of having orchestration available. So imagine you are building a .NET application and you need the Azure Storage Emulator. You maybe need a SQL database. Maybe you need an SMTP server because your application is going to send emails and all of that. What you can do with orchestration there as well is not only generate a Docker file that will host your IDE. Typically, what will also happen on those platforms, and Space does this out of the box as well, is that they run Docker on there as well. So if you have those requirements of requiring a SQL server, requiring a mail server, all of that, you essentially get a Compose-like solution where you can get those things started whenever you open your project in the IDE. So also there, if you have someone new who's onboarding to your project, they essentially open in IDE, it will spin up a SQL server, for example, and you have a writer remote IDE ready to go, and that can connect to the database and you can get started with it.
If you're enjoying this show, would you mind sharing it with a friend or colleague? Check out Podcatcher for a link to the show notes, which has an embedded player within it and a transcription and all that stuff, and share that link with them. I'd really appreciate it if you could indeed share the show. But if you'd like a few other ways to support it, you could leave a rating or review on your podcatcher of choice. So if you head over to .netcore.show/review, you'll find loads of ways to do that. You could consider buying the show a coffee. The Buy Me a Coffee link is available on each show's show notes page on the website. This is a one-off financial support option. You could become a patron. This is a monthly subscription-based financial support option, and the link to that is included on each episode's show notes page as well. I'd love it if you could share the show with a friend or colleague, or leave a rating or review. The other options are completely up to you, and are not required at all to continue enjoying the show. Anyway, let's get back to it. See, that's another thing that a lot of devs who've been working on a project for a long time don't realize, is that just getting things up and running, like you said, right? You got to install SQL Server. Well, which version of SQL Server? And that opens a whole bunch of ports on your computer. And then it's like, where do the database files go? And is it a good idea to store it on this drive or that drive and all that kind of stuff?
There's even a couple of additional benefits because you are not constrained to having just one remote development environment. You can have one per branch or one per feature that you're working on with different states of the environment as well. So imagine you have 2 branches where the database schema has diverged completely. Instead of having to run database migrations every time you switch your branch and hope for the best that your data is in order to get started again, you just essentially have 2 environments in that case for every branch with different types of data in the database ready to go.
I like that. That makes it so much easier, right? You're then no longer having to write maybe a script or a migration just to be able to switch branches, right?
Yeah,
Because
exactly.
I can imagine that could get really difficult to manage. Like, oh, I'm working in this branch today. Feature add this new table, which requires me to add 15 new database tables. Oh wait, I need to leap over to this branch, back to main or whatever, because I've got this bug fix in place. Well, now my database doesn't match the code. Oh, I've got to undo those migrations. Well, that's a manual process. But if I could just leap over to another server, essentially, and do the work there, It's magic.
It definitely feels like it, but it's so much more productive in those cases where you have to switch branches and essentially update the environment every time you switch branches.
I like it. So we talked a lot about how it kind of can help developers, right? But we touched on this a little bit. But like, what is it actually? Without giving away the secret sauce, right? I don't want you to get in trouble by telling me and the listeners, like, oh well, it starts with public static void, but like, what's the technology it's built on? Then we've talked about Docker a lot and Git pod, right?
Yeah. So the orchestration in space is our own implementation. I can't really talk about how that works. Well, I can talk a little bit about how that works. It's essentially Docker and VMs that are preloaded and ready to go, and we provision your Docker container on there, and you have the orchestration running, and you can connect to it. The actual IDE that is working remotely, I can talk a little bit about that as well. So all of our remote developments that we have in the IntelliJ-based IDEs is based on what we have been doing in Rider for a number of years now. So maybe give you a little bit of history. IntelliJ was a Java IDE and is still a Java IDE. It's also an open source project built on the JVM. So if you tomorrow want to start building your own IDE, you could use it and start working on top of that. We have ReSharper, which is a Visual Studio plugin that does all of the .NET stuff that you can do with ReSharper, and it's written in .NET. The two technologies don't really mix and match. One is JVM, one is .NET. And when we started thinking about building a cross-platform IDE, we had a couple of options. One was build a new WinForms or WPF UI on top of ReSharper. And you know how it goes. That would be a project that takes ages and will never get completed. The other option was to essentially rebuild ReSharper inside IntelliJ using Java and all of the tooling there as well. Again, same problem. That is a big rewrite that's taking 18 years of learning in ReSharper and replicating all of the features and bugs and edge cases and all of that in IntelliJ. So that was not a good option. And we started experimenting with bridging the two by using a communication protocol to essentially have IntelliJ send the command to a backend ReSharper and vice versa. We tried a couple of things there using a REST-like approach where you have a request response. Whenever you click something, it would fire off to the server, and then ReSharper would respond, and IntelliJ would do something with that. Turned out that didn't work at all, or at least it worked, but it didn't feel snappy. It didn't feel like you would expect your IDE to feel when you're working. So we started looking into making that better and improving it, and that's where we thought, okay, this view model approach may be a good approach to take. So we started building essentially a third IDE in terms of a view model, where there would be no logic in that view model, but still all of the state management and all of the things that could fire between two sides of the equation. I think I alluded already to that a little bit, where if you have inspections, for example, in Rider, ReSharper can say, hey, this line, this column, this character, you should show this inspection there. But at the same time, IntelliJ itself is also an IDE. So if you're working in a Razor file, for example, that combines HTML and C#, ReSharper may contribute to that view model, but also IntelliJ may contribute to that view model and essentially give you the best of both worlds, the best of both IDEs by just contributing to that view model, and based on whatever happens, where ReSharper or IntelliJ can pick up an action that you click. So that protocol is there. We have been using it in Rider for a long, long time now. It's also open source, so if you want to explore, it's pretty cool. You build the protocol layer using a DSL. So you essentially have a new programming language where you say, okay, I want to have this class with this collection of items on there. You click a button that generates codes. It generates JavaScript for you. It generates C# for you. It generates Kotlin, which is a JVM language for you. And you hook it up into your application and magic happens. You can use the language that was generated to contribute to that model, and the protocol layer will take care of communicating between things. So that's what we have in Rider. It's been there for a long, long time. And when we started looking into making pair programming possible with Code With Me, we thought, well, let's maybe see if we can reuse this protocol, because the protocol lives on a socket And in Rider, it lives on one machine on a socket. But what if we take two machines and just bridge over a network connection whatever is going on that view model? So that became our pair programming solution, Code With Me, where essentially two parts of the equation run on different sides of the internet, potentially. So that's the technology we used there. And then we started thinking, okay, we have this Code With Me. We already made this step of pulling apart a server and a client, where you can have one server, which would be the host of a pair programming session, and one or multiple clients, could be a classroom, for example, connecting to that host. So we thought, okay, we have that. Why not take this and make the hosts unattended, sort of run it on a server without there being human interaction, and have you, as someone who wants to work remotely, just connect to that host that is running somewhere. So all of that is working on the same protocol that Rider was built on top of.
Right. Okay. So it's all Rider's fault, is what you're saying.
Pretty much, yes. Yeah.
Oh my goodness. So I can imagine that. Now this, you may not be able to answer this. You may not want to answer this, but I can imagine that. With JetBrains being like a distributed team, you might possibly be using this to develop it. Is that what's happening? I mean, you may not be using the software. You may not be dog fooding it, right? But are you, just as a color sort of question, I'm interested to see whether you're dog fooding, right?
Happy to go into that. So yes, we dog food. It depends on the person. So we are very liberal in what you can choose in terms of the tooling you want to work with. So we have some people who essentially build from master every morning and use that as their main IDE to work on in the IntelliJ team or in the Rider team. You have other people just using stable. And we also use Code With Me, for example, if a developer on the team has a question about something, they jump into a pair programming session and have someone else join and work on that. Remote development as well. We have a lot of the developers on the Rider team, for example, work in Rider just to do their development, also in IntelliJ, because, of course, they have to work on the JVM version there as well. But as you can imagine, it's a massive project. I think Rider alone is 300 .NET projects, so it requires a lot of power. And maybe you're working on a longer-lived branch that takes a couple of days to work, to build. And we have some folks on the team actually using remote development in space to have that one specific branch running where they can just connect using either IntelliJ or Rider to connect to the server that is running there and continue working whenever there's something to be done on that branch.
Right, I see. and this what we're talking about now is different to space, right? So I know it as fleet. Is fleet different to space as well? Just because we've had the two words.
It's getting complex. Yeah, sorry.
Yeah.
So space is our one size fits all software development solution. Imagine it's like GitHub or GitLab meets Jira meets remote development. It's a server side product where you can work together on things, and it comes with an orchestrator for these things. You have IntelliJ, the IntelliJ ecosystem, so to speak. WebStorm, PHP Storm, Rider falls under that as well. That is the existing IDE. And then there's Fleet, that is the new IDE, completely separate. It can also run on a remote development environment running in space, but Fleet is a different IDE in that case, yeah.
Right, I see. And Code With Me is yet another thing, right, that allows you to do that collaborative remote development. Yeah. So we're not just talking about me sitting in front of a machine using another more powerful machine to do the heavy lifting. We're talking about you and me working on the same code base that is perhaps on my machine, but you're dialing in, right?
Yeah, exactly. So Code With Me is the technology or feature, depending on how you want to call it, that we have in the IntelliJ ecosystem to work together on one code base. So we see teams and team members using it to work together on something, to step through some problem that they may be having, debug together and see what is going on, do actual mob programming as well. I know we have some folks having tried that, working on the same thing with a couple of people, just crunching out code on one machine who is the host, but they can all write code in that environment. At the same time, we see Code With Me being used in classroom environments, for example, where the teacher has the host privileges, and they can have the entire classroom follow along, even during a debugging session, give everyone the opportunity to inspect variables and all of that are in there, while it's only running on one machine in that case. So that is there. Then remote development, same thing, except the host is a server that has no human involved at all. Currently, the server in remote development can only have one client, which means it's your server and you can connect to it. I think the idea is to also make it possible to have one server with multiple clients, so you can do remote pair programming or remote mob programming if you want to. And I think it's not there by far, but I think that would be a really cool thing where you can schedule remote development sessions, for example. So imagine every Thursday morning between 9 and 10 a.m. we work together on a random problem. What you could do in that case is maybe use that orchestrator to spin up a machine by 9 a.m. so that everyone who wants to join can just connect to it. The machine is ready. You can start working on it and play with it.
I like that. That feels like it would help. Like you said, you mentioned about perhaps using it in the classroom, right? I like the idea of being able to sort of help with knowledge sharing, right? So we spin up something to facilitate the video portion of me and you chatting away, right? Maybe it's Zoom, maybe it's Skype, maybe it's Google Meet, whatever. And then you say to me, look, here's just join my code with me session, and we'll walk through it, and I will talk you through how the code all fits together, right? And then I could then like independently of you, I can be like, but what does this code bit do? And I can go off on my own little journey and investigate things.
Yeah, that's actually a couple of the modes that are available in Code With Me, and you can just switch as you go. So there's a mode where every guest can just browse freely, roam freely through the code base. There's a force everyone to follow you as a host, where you can say, okay, everyone, my cursor is leading. Whenever I click a new tab, whenever I go to a new file, you will see the same file and the same line of code that I'm selecting. So it depends on the situation. You can switch back and forth pretty much continuously. There's also an interesting thing in that it's not only the codes that you're sharing. In that case, you're also sharing the full IDE, which means that guests connecting to you using Code With Me could get terminal privileges as well. Now, of course, that's something where everyone who connects and gets that privilege always tries to type rm-rf to remove your root file system. So that's why we don't enable some things by default, but you can open it up. So if you're teaching something where the command line is required as well, you can show students in such a classroom setup what the Docker commands or the Git commands on the command line would be as well.
You see, I like that. I really do. Okay, so we talked about how Space is this one big server solution that has everything you need. It's got project management, it's got your tooling, it's got all that kind of stuff. Is that something that I can do on-prem, or is it something that's on your servers, right? So like if I put my project manager or CTO hat on, do I need to build a server myself, or are you going to happily sort of let me run that on some infrastructure you spin up or something?
Yeah, so Space started off as a cloud solution. And actually, even at the time of recording, I think my colleagues are currently making the on-prem version available. So especially by the time the recording will be up, it will be available, where you can run Space on your own infrastructure. Now, of course, Space is quite complex. There's Git hosting, there's all of the other stuff, there's the remote development. You want to make sure that things are secure and all that. So there are some requirements where you need either a Kubernetes cluster. You can actually try it locally if you use Docker Compose, but you will need a very beefy machine to run all of the components in that case. But essentially, we will require you to have a Kubernetes cluster ready to go with certain policies set up and all of that. But yes, it will be possible to run on-prem.
Excellent. I really like that idea too, because like I've worked with some clients in the past where they're like, well, yeah, we'll use Jira because, you know, we can just go to Atlassian.com and, you know, whatever. We're not sponsored by them. I'm just saying that's an example, right? Everybody knows that one product. Or, you know, we'll go to Azure DevOps and we'll do it that way, or GitHub project, or, you know, we'll use GitLab or something, right? But then we've got to go else. We've got to leave that ecosystem and go elsewhere to get the code, and then we've got to leave that ecosystem and go elsewhere to get the tools, right? And yeah, just for simplifying things, I like the idea of just I go to one place and it's all there, right?
So yes, you can use Space completely, all of the components that are in there. But if you want, if you're using best of breed in your company, what you could also do is just use the remote development or the remote orchestration part and combine it with whatever existing issue tracker you have. So you can mix and match however you please.
Sure. Okay. So I'm not sure about the phrase, but there's like a one-stop shop solution, or you can pick the parts that you want and use whatever you like. I like that. Gives people the option, right?
Yeah, exactly.
Because I have worked with some clients where they're like, yes, we'll do that, but we want everything, 100% under our control, or we don't want to change this, because I can imagine exporting data from one tool and importing it into another takes a lot of time, right?
There's that, and also the integration of all those tools. I mean, maybe you're using Slack in your organization. If you go look at the number of integrations with third-party tools, there's going to be integrations with, PagerDuty to monitor uptime. There's going to be integration with your CI/CD to get build status notifications. There's security across all of those different tools, and it's a lot of things that you have to manage and make sure that if someone leaves the company or joins the company, they have access to everything. Maybe at some point someone set up a connection in Slack, they leave the company, and all of a sudden for a week you no longer get CI/CD status notifications. Things like that you have to take into account, and that is of course where this all-in-one solution shines, where everything is just one thing that has all of those things out of the box.
Cool. Okay. Well, this has been a very interesting conversation for me, because like I say, I'm all about that remote development, and I'm all about speeding up the adoption of, or the onboarding of a new member of the team, right? So for instance, with the apprentice that we have, after sourcing the hardware, it was a case of, well, they're going to be running Windows because they're running Windows because they need Visual Studio or whatever. It was, reformat the machine, install, and I sat it next to my work machine, and I was like, okay, run this script that will install all the apps. And it was doing it for 2 or 3 hours, just installing apps silently, and I'm working away. Then finally it's like, ding, done, excellent. So I log in as the apprentice, and none of the apps are installed. I've got to run the script again because I didn't do it install for all users, So that's another 2-3 hours of just sitting there watching a progress bar. So I like the idea of being able to, in effect, once you've set it up, effectively push a button and you've got all your tools, right? I love that.
Yeah, absolutely. That is a thing. It makes development so much nicer. Actually, Space, the orchestrator that we have, also has a massive SDK available, where you can essentially everything that you can do through the UI, you can also do through the API. And I mentioned I'm a developer advocate, but also developer as part of that. So I work on that SDK for the .NET side. So if you want to integrate with Space using .NET, you can log your bugs with me. But the interesting thing is I use remote development there because to generate part of the code against the latest API specification that we have, there's a lot of hoops that I have to jump through in terms of making sure that I'm authenticated, that I get the right set of APIs to access and all of that. And I use remote development there, and Space injects the secrets for me into that environment, so I don't have to care about that. When I switch machines, when the keys rotate, whenever something like that happens, I can still just open that remote development environment and start working on the SDK there, which is mind-blowing in my opinion.
Yeah, that's one thing we didn't really talk about was secrets, right? So that might be your connection strings, your API keys, your whatever's. Managing those is if we're in an ASP.NET Core context, we've all got app settings.json, but then you do git add dot, and whoops, you've just added it to source control. Yeah, you've got user secrets, but then, like you say, when you move machines, you've got to take that JSON file with you.
Yeah, exactly. Yeah, that is there in Space, for example. I know Gitpod has the same thing where you can set environment variables and environment secrets, and you can load those into the IDE. A small tangent here for listeners who may be using 1Password. That's something that I discovered last week. They also have something like that. So if you don't want to work with remote development or anything like that, you can actually have passwords in one password and load the secrets on your development machine from that thing as well. Just as a small side note there. I was pretty enthusiastic about it.
Yeah, that's pretty cool. Yeah. Wow. Yeah. And then with things like that, you don't have to worry about who has the keys to the castle when they leave, right? Because, so as an example, when I stop working on a project for a client, what I do is I'll generally wipe the machine and start again, right? Because all of the tools that I use cache everything, right? Including, well, I would hope not including all the secrets, but then I've also got all of the secrets on the machine. Wipe the machine, then theoretically, unless I go to a data recovery company, I no longer have any of that information. Using something like these remote development tools, I don't need to do that, and I don't need to worry about that because it's all on the server, right?
Yeah, exactly. and not only connection strings and things like that, but also the source code itself. I mean, yes, you can run a zip on the remote server and then somehow get that zip file of all of the sources to you, but during the day-to-day work, you probably won't be doing that. So what you have is that the source code lives on the server. You leave the company or whatever. You can even take the laptop. There's nothing on your laptop except that at some point you connect it to some remote development environment that you now no longer have access to.
I like it. Well, Maarten, this conversation has really enlightened a lot of stuff in me, and I'm very excited to check it out. All of the different things that JetBrains have got cooking up. Especially space. I love this idea. But so what about getting in touch with you or learning more about all of the different stuff we've talked about today? Have you got some, I can see, so for the listeners' benefit, we have this document that we have backwards and forwards. I've already got a bunch of the links. So whatever links you're about to shout out, they will be in the show notes. But what are some of the ways that people can get in touch with you or learn a bit more?
You can find me on Twitter. That's the place that I'm active on. I tried TikTok last week, but I gave up, so that's not going to work. So yeah, you can reach out on Twitter. I have a blog. The company has blogs for every separate product. There's the landing pages, and we try to give you as much information as possible on how to get started for many things, including Rider, including remote development with space, for example, as well. There's some background blog posts that you can find as well. So if you're interested in learning more about the technology, not into the very detail, but high level, how everything fits together and how everything works together, then you will find those things as well. So definitely check out the links in the show notes.
Awesome. Thank you ever so much. Well, like I said earlier, thank you for this wonderful, enlightening conversation, and I can't wait to get my hands on space and give it a try, because it sounds like it's going to be really, really simple for throwing together these applications, and especially if you're managing a large team of developers, maybe they're all working on different projects. It seems like it's kind of like the next big step, right?
I think it is definitely the next big step. And I think not only if you don't look at JetBrains, but look at other competitors, you will see similar flows of companies going the remote way and getting everything together and getting essentially the code and the resources off of the developer machine and onto something more powerful and more secure.
Excellent. Well, like I said, Maarten, thank you ever so much for this conversation.
Thank you for having me.
Hey, no, you're very welcome. That was my interview with Maarten Balliauw. Be sure to check the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave a rating or review on your podcatcher of choice. Head over to .netcore.show/review for ways to do that, or to reach out via our contact page. That's .netcore.show/contact. And to come back next time for some more .NET goodness. See you again real soon. See you later, folks.
The .NET Core podcast is a production of RJJ Software Limited.